All right, folk. Let's get started. This is 7.2, day number 1. We're going to sketch some rational functions looking at asymptotes, intercepts. We're not going to talk about the can lab yet, but we will donate the cans that we do bring in eventually to food shelf. So let's have a chat here. There's can lab info. We can talk about that later. Let's go through this practice real quick and do this together. Domain, right, of this function, this rational function. Whenever I look for domain, I look for a square root or an even root, right? And then I look for what would make the denominator equal 0. So the domain of this function would be anything except for two values, -1 and a +3. So that tells me right there, there's either going to be a whole or a vertical asymptote at those locations. Okay? Now, in order to determine whether or not there's a whole or vertical asymptote, I got to factor that numerator in order to see if a whole shows up. So I could factor that x, let's go -9, and how about an x plus 1? Cool. So I'm identifying that there's going to be a whole at what value? Yeah, x equals -1. Okay. And we could find the y value for that, but we're not going to do that right now. We'll do it in a little bit when we graph. Okay. So we could find that y value, but we won't do it quite yet. All right, vertical asymptote would happen where? At 3, correct. All right, it's the other factor in the denominator that doesn't have a duplicated factor in the numerator. So the vertical asymptote here would be at x equals 3. All right, horizontal asymptote will be related to degree on top and degree on bottom. What would be the degree in the numerator? Yeah, I'd have an x squared, right? I'd have an x squared plus a bunch of garbage after that. And in the denominator, I'd have a 3x squared plus a bunch of garbage after that. Now, you realize that as x goes to infinity, x squared would grow a whole lot more than -9, right? So the -9 becomes irrelevant. And actually, so does the -8x, because x squared will grow so much quicker than 8x that we can kind of visualize just leading term over leading term. If these two are the same, which they are, I've got a 2 and a 2, I take the coefficient of that term, and so I'd have a horizontal asymptote at y equals 1/3. Boom, done. So I have a nice little template for when I sketch. Right? Okay, let's look at the second one. Let's just chat through it real quick. Let's fire some of these answers out there. Domain is everything except for what values? 0 and 5, good. Which of those will be a whole? Neither, right? Neither. I don't see an x up here. No, I don't. And I don't see an x minus 5 up here. No, I don't. So there will be no holes, none. So that means I've got two vertical asymptotes. How's that even possible? Well, it is. Okay. Joey. Okay, and in horizontal asymptote, what's the degree on the top? X to the 0, right? And the degree on the bottom would be x squared plus some garbage. So since the degree on top is smaller than the degree on bottom, we have a Bob situation, bigger on bottom. And therefore, since Bob is a 0, we've got a horizontal asymptote at 0. Oh. Now, watch this for just a moment. Let me take this function g of x. G of x equals -4 over, let's go, x squared minus 5x, right? If I were to take the limit as n, excuse me, I'm in calculus class right now, as x goes to infinity of this thing, right? I plug an infinity in. That means I'm going to have infinity squared minus 5 times infinity. Okay, here's the thing about infinity. I can't really determine much other than the fact that if I take infinity and I square it minus 5 infinities, I'm just going to have this. Infinity has no specific value. So what would 4 over really, 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 really large number be? Right, which would be really close to what? 0. Which would be approximately 0. Which is why this function never actually equals 0, but it approaches 0, right? There's an asymptote there. So as the denominator gets bigger and bigger and bigger, whether it's positive or negative, the numerator stays the same. So as the denominator increases, the whole value decreases and it approaches this value of 0, whether it's coming from the top or from the bottom. Makes some sense? That's end behavior. Okay, let's continue. All right, this is one method and one way we could do this. I'm going to show you how to do this, I think, on the next slide. Not quite this one. This is an example of a slant asymptote. We're going to get something like that in a minute here. So let's sketch this thing. Let's find the domain. Oh, okay. Domain. Based on my rational functions steps for graphing, the domain of this thing, the first part, will be x is not equal to -2. What is -2? Asymptote or whole? Asymptote. Okay, so at -2, I'm going to put a -2 right here, which, oh, go figure, equates to that. I'm going to put an asymptote. All right, cool. Part 2, reduce to lowest terms if possible. Did I factor anything? No. Can I reduce anything? No. So, ain't nobody got time for that. Ain't nobody got time for that. Okay. I don't need to, right? Okay, cool. Number 3, find the x-intercepts and y-intercepts of the graph. What will that help me with? Potentially. Right, what would the horizontal asymptote be here? Do I have Bob, Bot, or Sob? Bigger on bottom, right? So I'm going to have y equals 0 as a horizontal asymptote. So will there be any x-intercepts? No, there won't be. So no x-intercepts. X-intercepts, none. Well, how could I find a y-intercept? What would I plug in for x? 0. Plug a 0 in for x, and I get something out for y. Well, if I plug in a 0, f of 0, this would be a 0, so that'd be 4 over 2, which would be 2. Okay, that helps me. So f of 0 would be 2. This is the point 0, 2. Well, that's helpful because that tells me this portion of the graph will be above the horizontal axis and to the right, obviously, of the vertical asymptote. Ooh. Number 4, determine the location of any vertical asymptotes or holes. We've already done that. Analyze the behavior of this function on either side of the vertical asymptote. So here's where we'd analyze behavior. We've already said here at 0 that the graph will be above. Right? If we were to take a guess, where do you think a value for -3 would be? Above or below? I'm going to guess negative. It's probably a good estimation, a good guess, right? So the graph will be below 0 to the left of -2 and above 0 to the right of 0, or to the right of -2, excuse me. Okay, so what's our last step? Use a sign diagram and plot additional points as needed. Okay, so let's plug -3 in. We plugged 0 in, f of 0 equaled 2. Let's plug -3 in. F of -3 would equal 4. Let's plug in -3 right here. 4 over -1, so it'd be -4. And that, you guys, is how we would isolate this. So -3 would be -4. 1, 2, 3, 4. All right, so our sketch of our graph would look like this. Cool. Typically, rationals will alternate the side of the horizontal asymptote, but not always. Okay, typically they will, but not always. All right, let's continue on to another example, and then I want to talk about slant asymptotes. Oh, Hello, slant asymptote. How do I know that? Because the degree, what, Luca? Say it. The degree on top is larger than the degree on the bottom. By how many? By 1. So if the degree is different, top is 1 greater than the bottom, the asymptote will take on the shape of a line if we did long division. If the degree on top is bigger than the degree on bottom by 2, this is really cool, you guys. The asymptote will take on the form of a quadratic. Yeah. Yeah, it's pretty filthy. So watch what happens here. Let's talk about this. First, let's factor the numerator just to see, right? Just to see. X minus 3, x plus 2. Okay, do I have any holes here? No holes. Do I have any vertical asymptotes? Yes, I do. At what? -1. Okay, so I've got an asymptote here at -1. Okay. Oof. Do I have a horizontal asymptote? Technically, by Bob, Bot, and Sob, it's bigger on top, right? So the graph goes to infinity. However, if this is greater by 1, I'm going to do long division. You ready? Actually, I'm going to do synthetic division because that's going to be nicer to my brain. So I'm going to use -1. What would my coefficients be? -6, right? Okay, I'm going to do this. Drop down. Wow. Multiply. Wow. Wow. Uh-oh. Oh, this is going to be ugly. Oh. Oh. Gross. Okay. Fine. So the slant asymptote, I know this isn't going to be nice, you guys, but is going to be x minus 2. I thought this was going to be cool. Minus 4 over x minus 1. Wouldn't it be nice if that just came out to be a nice stinking like that? Yeah, that would have been nice. What a terrible example to use. But it's what it is. So the point of doing that is this. What would the graph of x minus 2 look like? Well, it'd go through this, right? -2. And it'd have a slope of 1, right? So the asymptote actually looks like that. Yeah, it's pretty gross, right? No.
What's the 4 over x minus 1?
Well, that's kind of a little something. We could sketch this with the graph. You know what? We'll put it on TI Smart View, and we'll see how close I get. Okay. But let's just test this. Let's test a number. Let's test a number like -2. Okay. What would the value of -2 into this function be? F of -2 would equal. Let's go -2 minus 3, so that's -5. And -2, that'd be a 0. So over -2 plus 1, which would be -1. So we get 0 over 1. That'd be a 0 value, right? That'd be 0. We okay? No? Let's sketch it on SmartView. Let's pause. Children at home, plug this function into SmartView. That's your calculator. Children at home, we just sketched this using our graph, and look at that. Now let's go back to our slide here and check this out. Does that look relatively close to what we had on the graphing calculator? Yeah. So I took f of -2, and I got 0. So f of -2 is equal to 0. F of -2 equals 0. So I know the sketch, this graph will be like that. Let's test another number to the right of 1, or -1. Let's go 0. Well, that'll be nice and easy. If I plug a 0 in here and here, I'll get -3 times positive 2 over 1, which is negative 6. Okay, it's going to go off my graph here, but 0, negative 6. So it looks like, oh, chow. Cool. Now I want you to see a quadratic slant asymptote. So I told you before, doesn't it sound awesome? I've told you before what's different. What do we want the difference between the 2 degrees to be? 2. So let's change this to an x cubed. Let's see. I have no idea if this is going to turn out well or not, but let's just try it. Does it? Yeah, you guys, it's just filthy how awesome this is. Get ready. Straight filth. Grab that. Oh, how big's your window? Okay, I'm gonna expand my window here. Let's go zoom fit. That'll work. Zoom fit, 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 fit. Where are you? Is it 0? Check this out, you guys. Watch how awesome this is. What does this look like? Oh, quadratic. Oh, you guys. How awesome is that? I'm verified, so I can do this right now. You have no idea how awesome this makes it. It just makes me feel. What if I went to a difference of 3? Oh, get ready. Get ready. It's about to get nasty here. Let's go to the 4th. Let's go to the 4th. Well, let's see how awesome this is. Hold on, zoom fit. Zoom fit. What the heck? Let's make this look nicer. Okay, here we go. Get ready for an awesome asymptote. Oh, here we go. Cubic. Yeah. Yeah. And then, of course, we had negative 1, right? Yeah. Like, subscribe, comment below.